This is the last video of chapter 16 called Accurate Timing Timers of the Crystal Clear Electronics curriculum. Szabolcs, where did we stop in the previous video?
We discussed the benefits of timer peripherals and quartz crystal, so the following example shows how to use them. The properly modified circuit diagram is shown in figure 6. Although the use of an external crystal usually requires the use of two capacitors between the two legs of the crystal and the ground, according to section 8.9 of the datasheet, it's not required in this case. The concept of the new software is the following. At startup, we set up and start the timer peripheral, then we execute 3 tasks in an infinite loop. Scan the state of the buttons, update the display, and wait until 1 second has elapsed. Let's start with the setup timer function. This function configures the timer counter 2 peripheral by following the steps. First, it configures the timer to use the 32,768 Hz oscillator between the TOSC1 and 2 pins as input by setting the AS2 bit in the ASSR register. Then, it configures the prescaler to divide the above 32,768 Hz clock signal by 1024. Thus, the control logic of the counter will have a 32 Hz clock. Thirdly, it sets the timer to clear timer on compare match mode. In this mode, the counter counts between 0 and OCR2, and at every overflow, the OCF2 bit is set to 1, as can be seen in figure 17.11 of the datasheet. Fourthly, it sets OCR2, that is, the upper limit of counting, to 31, so the counter will count between 0 and 31, which means that an overflow will be generated at every 30-second beat. The 32 Hz internal clock signal causes the timer peripheral to set the OCF2 bit to 1 once per second. This flag will then be periodically restored to 0 by our program. Finally, it starts the timer. The prescaler setting in the ATmega16A microcontroller also starts the timer. It can be seen in table 17.6 in the datasheet. Accordingly, combining points 2 and 5, the implementation of the function may look like this.
It's worth mentioning that we also implement the program in this order as we read, based on the author's logic. We first clarify and outline the high-level concept. Then, we start to build our main function and what steps we want to perform in our code. For example, setup timer, check if second elapsed. Then, we create the necessary data structures, and finally, we get involved in interpreting and reading the datasheets and implement the low-level logic operations, register writes and reads.
Az alacsony logikai műveleteket, regiszterírásokat, olvasásokat. Sokat segít.
It helps a lot to explain how the program works to a competent friend or colleague. Often, even while explaining, you realize that your program is not correct or unnecessarily complicated.
Feleslegesen bonyolult. A legjobb programozók, akiket is
The best programmers I know regularly consult a colleague, and not only when their software doesn't work. This activity is known as a code review.
angolul code review-nak hívjuk. A kódolás
The best time to review your code together is right after the compilation of your program.
után van. Ekkor már a fordító megtalálta,
At this time, the compiler has already found the most trivial errors,
de még nem töltött
but we haven't yet spent time uploading and debugging a faulty code.
hibák megkeresésével.
Szintén a timerrel foglalkozunk.
The check if second elapsed function also deals with the timer.
Ennek a függvénynek
This function must return true if the timer has reached the set maximum value, that is, if another second has elapsed, or false if it hasn't.
false értékkel, ha még nem. A timer periféria
The advantage of using a timer peripheral is that this function is very simple. The peripheral works in the background regardless of what operation the microcontroller is executing.
abban a pillanatban,
The moment a full second elapses, the hardware will set the OCF2 flag in the TIFR register,
regiszterben,
and this flag will remain in this state until the software sets it back to 0.
nulla értékre. Ezt az adat
This is shown in the figure 1711 of the datasheet and the OCF2 bit description in section 1711.6. The value of the TIFR register can be changed in a strange way. The value of a bit can be reset by writing 1 into it. If you write 0, it does not change the bit value. Why is it better that I use the second elapsed b variable instead of using toReturn?
Vissza a függvényből két return utasítással. Bár a fenti egyszerű függvény,
Although the above simple function would have been understandable anyway, in general, it is easier to understand, debug, and maintain a function that has only one exit point.
visszatérési helye, angolul exit pointja van. Szoftverfejlesztés.
Notice that there is a lot of time in troubleshooting and fixing errors during software development. But what does the b mean at the end of the second elapsed b variable?
Sok kellemetlenségtől kíméljük meg magunkat.
We save ourselves and those who later want to understand our program from a lot of headaches beyond measure if we write the unit of measurement in the variables' names.
A kétértékű
Boolean variables are often denoted by the _b suffix. From this, it is visible at a glance that the second elapsed b variable has values true or false
false értéket vehet fel,
depending on whether a second has elapsed or not.
telte vagy sem.
Érdekes.
It's interesting that NASA's spacecraft, the Mars Climate Orbiter, was lost due to a preventable error. There, one software module returned the engine-generated momentum in imperial units as opposed to the required SI metric units. That's how the result of a $193 million development burned up in the Mars's atmosphere.
Az update display
The update display function is the same as it was in the previous program because the function was written to be independent of the timing.
függvénytől. Másrésztről, így
On the other hand, if you later want to use a 7-segment display instead of the LEDs, or write the time to a serial port in text format, you will only need to make a few changes in the software.
ha egy másik projektben
If you want to use the same function in another project, it will be easy to move large sections of the program.
a tananyag honlapján
The curriculum website has a version of the example code that is yet to be completed.
próbáljátok meg
Fill in the missing parts marked with to do, upload the program to the microcontroller, fix any bugs, and admire your much cooler gadget.
ki az esetleges hibákat. Ebben a tananyag
In this chapter of the curriculum, you have learned about the following: what difficulties we face with timing without using the timer peripheral, how to use the timer peripheral, and how to make software development easier.
a timer perifériát ebben a részben
We use the timer peripheral in this section in timer mode. In the following chapter, in chapter 17, we will discuss how to apply it to generate PWM signals.
PWM jelek előállítására.
Köszönjük, hogy velünk tartottatok.
Thank you for joining us for the episode on accurate timing timers. We hope you learned a lot of useful things from this episode and that you will no longer have problems when it comes to timing. You can download the curriculum in PDF format from crystalclearelectronics.eu or in Hungarian from kristálytisztaelektronika.hu. You can find a mobile app for Android and iOS platforms with the same name.
Kövessetek minket.
Be sure to follow us on Facebook and see you soon in the next videos. Bye!
Bye!